All right, cool. So we're recording now. So today we're going to be talking about a few topics. So we'll start out with reviewing linear search, and we'll talk about one particular feature of Python called list comprehensions. And then Akash is going to talk to us about coding standards and PEP8 and linters and things like that. So we'll do that, and we'll take a little break. We'll come back and we'll talk about something called test-driven development and unit testing in Python. And we'll take another break, and then we'll talk about debugging in VS Code and using Jest, which is a testing framework for JavaScript. So yeah, so we'll go ahead and start off. So Dylan has bravely volunteered. So we're going to take a look first at Dylan's code. So let me pull it up. All right, let me share the screen. All right. So Dylan, does that look vaguely familiar to you? Let me get Dylan to be able to talk real quick. All right, Dylan.
Can you hear me?
Yeah.
Cool.
All right, cool. So this is your code, right?
Yep, that's it.
All right, it's your last chance to deny.
No, I don't want to deny it.
Okay. All right, so can you just walk me through what's happening?
Yeah, so the README said for the first one that you just want the first instance of what you're searching for in the array. So I made a for loop to basically loop through the array from 0 through the length of the array. That's what range, length, and then the array is. And then if the value defined matches, basically the first match that it hits, if it does match, it's going to return that index in the array. Otherwise, it's going to return none if there's no hits.
Okay.
And then the second one, it said to return every instance of a hit. So I made an empty return array. I did the same thing. I looped through it with a for loop for the length of the array. And then if it hits, it's going to append into that return array. And then if the return array is greater than 0, so basically if there were hits, it's going to return the return array. Otherwise, it's going to return none.
Okay. Yeah, so this looks good to me. So this is, you have linear search. So the first one, the value defined in the array to search through. So if I call this with, so linear search with, let's do 1. I'll print this out. Okay, I get 3, 0, 1, 2, 3. It looks like that works. Okay. So you have a for loop here. You're running through the range. Can you tell me about the range function?
Yeah, it basically goes from 0 through whatever the number you pass into it is. And since so basically length will give you the length of the array. So in this instance, it's it would be 5. So it would go from 0 through 5, but it's actually only going to go through 0 through 4. It goes
Right.
1 less than the number you pass in,
Okay.
which is fine because the way that arrays are counted starts with 0 rather than 1.
Exactly. Right. Okay. So we've got a for loop. So if this were JavaScript, not that I want to confuse people with JavaScript, but how would you do this with JavaScript?
For parentheses, let I equal 0, semicolon, I is less than array dot length, semicolon, I plus plus.
Yeah. So, one of the things that Python is known for or liked for is that it's very simple and expressive and brief, or concise, right? So there's all kinds of things you can do with this basic for. So for whatever in whatever, you can use range, which is actually a generator, which we can talk about later. But you can use enumerate. You can use the specific array that you want. You can use the actual array. And then you're iterating through every single one, and then you're grabbing the one that you want. Now, linear search, there's all kinds of different search functions that we have. And actually, you talk about algorithms and interviews and things like that. Searching is a very important part of the basic knowledge base that you should have. So do you happen to know anything about, again, we're not talking about this now, but do you happen to know anything about big O notation?
No, I don't know what that is.
Okay, so that's fine. So when you think about code, one way to think about it is in terms of how many operations have to happen given the size of your input. So if I give this function that you wrote an array that's length 5, it will, in the worst case scenario, it will have to run 5 operations, right? It's gonna have to loop through this 5 times. And if the value isn't there, then it'll return none. If I add 1 more, so it's 6, then I have to run through this 6 times. And if I add 10 more, then I have to run through it 10 more times. So the size of my input is correlated exactly with the number of operations that I have to run. So for every 1 I add to my input, I have to run 1 more operation. So that's called O of n. Again, we don't need to know that right now, but just to let you know that's one way of talking about code efficiency, if one solution is better than another. Okay, and then for the global linear search, you have you create an empty array, you loop through it using the same construct, using this range. So is there a way to maybe simplify this a little bit? So using range and length of the array, and then you're trying to essentially get an index, right?
Yeah.
So is there, in Python, you can actually just access the element directly. So in JavaScript, you can't do this, but in Python, so we could do something like for element in array to search through, and then if value defined is element, oops, let me add the colon, return something like that. Let's see, 0, 1. That should not have returned 1. Let me linear search.
I think it's returning the actual value of 1.
Oh, right. Okay, so that's right. My bad. So so here we actually do want to return the index. So another alternative that we can use is we can use something called enumerate. So enumerate array to search through. So enumerate will give us a tuple, so it's a pair, an ordered pair of the index and the element, the actual value itself. So we can check the value and then we can return I. And so this also works. So this works fine. You can use range and then length essentially to access the index. And then when you compare the value, you can use the index to access the array and then compare the value, or you can do something like this in Python. I mean, you can argue about which one is simpler. I'm not sure, but so I will give you access to the index. Element will give you access to the value itself, and then you can compare the elements to the value and then return the index here. So like everything in code, there are multiple ways to do this stuff. So I'll comment this out. And I just, I also want to mention, so there's another kind of feature. So we talk about things that are unique to Python, or if you start reading more about Python, you'll hear this adjective Pythonic. So this is the ideal. Your code should be Pythonic. And what that means exactly is, people like to argue about these things. And Akash is actually going to talk a little bit about what Pythonic code might look like. But for now, I want to talk about something called list comprehensions. So if we look at this second example called global linear search, we have a whole lot of lines here, which is fine, right? So we create an array, we loop through it, we append to the array, and then we return the array. So that works, and that is perfectly fine. So there's another way that we can kind of do this thing. So we learned about map yesterday. So JavaScript has map, Python also has a map, but so map is a higher order function. It returns an array, right? It starts with, it takes a callback function, and map will execute that callback function on every single item in the array that you give it. So it's gonna iterate over an array that you give it. It's gonna execute a function on every element, and it's gonna create a new array that will return the values that your function runs on it. So there's something in Python that does that same thing, and it's called, the syntax is a bit weird, but it's very Pythonic. So if you want your code to be Pythonic, you should use list comprehensions when possible. So the way it works is, so we have an array here, so we can access the array. So for element in array. So if I just wanted to make a copy of this array, I could do something like this. I could do element for element in array. So this syntax is a bit weird. It's kind of, in some ways, it's the opposite of what you have. So we have the for loop here, and then this is the equivalent of for element in array, add element to my array. So I'm going to set this equal to a variable. I should use snake case here. And we'll print new list. So if we run this, we pass in this array 2, 4, 5, 4, 1, 3, and we so so why is this happening, Daniel? You're still on the line. You're still on the line, I guess. So can you tell me what's happening here? Why is none showing up?
Yeah, because basically every functions usually have a return value. And if it doesn't have a return value, it's defaulting to returning none.
Right. So this function, especially when you're starting out and you're working in the REPL and everything, it can be difficult to grasp the difference between printing a value and returning a value. So this is something that, many of you are likely to have been confused about in the beginning, as was I, right? So you run a function and then you see some output and say, okay, great. But this is not actually returning. This function is not returning anything. It's just printing to standard output, which is the console in our case. So the function isn't returning. So if it doesn't return anything, Python will automatically make it return none. And do you happen to know what JavaScript returns in the same case? So if I write a function in JavaScript that doesn't explicitly return anything.
Is it null?
Yeah, so it's it's actually
undefined?
it's undefined. So potato to a certain extent, but yes. So JavaScript returns undefined if you don't explicitly. So the same basic functionality exists in Python and JavaScript. It's just that in Python there's this none type that returns. In JavaScript it's undefined. Okay, so back to our list comprehension. So I've made a new list here. So I've iterated over every element in this array that we've gotten as a parameter, and I'm creating a new list populated by element. What if instead of just making a direct copy, I want to double every number in the array? Well, you can do that pretty easily. You just do, it's not just the element, but it's the element, it's double the element. So element times 2. So now we have element times 2. We run this and we can see that all of these have been doubled. We can also add, so this is like map, right? So in JavaScript, this would be the function we would want to use a map for. I have an array with a bunch of elements. I want to modify each of those elements and return a new array that's the same length as the original one, right? But what if I want to filter my array? So I want to have an array and potentially return a smaller array, so not the same size. Well, in JavaScript, you would use a different function. So you'd use map for one thing, and then you'd use filter for something else. In Python, using a list comprehension, you can use the same structure. You just change how you do it. So we'll do element for element in array if elements, let's say if it's odd. So you can run this and we get 513. So only the odd numbers show up. So again, the way this works is we're looping over or iterating over every element in this array that we're given. And we want to return this element. So we're going to populate a new array with this element under this condition. So if the element, so in the first case, so it's 2. So I'm looping over every element in this array. So 2, 5, 4, 1, 3. Okay. I'm going to check the element. If the element mod 2 equals 1, so if it's odd, then I'm going to add this element to my new list. Otherwise, I'm just going to keep going. So I go to the next one for the element array. So if the element mod 2 is 1, which it is, then I add it to my array. So it's the same process. The syntax is a bit funky, but it's a very flexible structure. So I can also do something. So up here we use the enumerate, right? So we have an array, we use enumerate, and we get enumerate will give us the index and the actual value itself. So you can do something like that here. So we can do, if I want to get an array of indexes. So we get index for element in, not in array, but in enumerate. Okay, I'll take off this condition for now. So if we search through this, you get just the indexes. So 0, 1, 2, 3, 4. So here we're using enumerate. Again, this is just the array that we're given, and we're returning a brand new array. So this array hasn't been touched. So we use enumerate to get essentially a bunch of pairs of indexes and values. We're iterating over it, and then we're adding the index to our new list. So we can use this to solve our problem here, essentially in one line. So we can use I for I element in enumerate array if element equals value. You can try doing that. And we get 0, 1, 2, 3. So the third index here. So if we added another 1, you get 3, 5. So the index is 3 and 5. So again, this is very counterintuitive at first, but it's a very Pythonic thing. So if you're really into Python, then you should start looking into list comprehensions. But what we're doing here is we're, again, looping over this enumerated array. And we're going to add the index to our new array if the element, which is each element in this array, is equal to the value that we're looking for. So this is a way of filtering an array and returning an array. So we could potentially do this all in one line. Now, I'm not saying that it's always better to do, one-liners, because depending on all kinds of, so readability is a, somewhat subjective thing. So depending on the people you work with, if the people you work with are not familiar with Python, then something like this might be not readable for them, and you might want to use something like this. So this might be more maintainable, more readable, depending on your context. But this is definitely a major feature of Python. So I just want to talk about that. Okay, so thanks, Dylan. Sorry that was a little wordy, but so good. So you solved the problem. That's great. I just wanted to show a couple other possible approaches to solving the problem. So thanks, Dylan.
You're welcome.
All right, so I'm actually going to hand it over to Akash. And Akash, I don't know if, do you want to take a quick break, Akash?
I'm ready to go.
Okay, cool. So yeah, I'll hand it over to him and take it away.
I'm unable to start my video, but I guess I'll just screen share right now. 1 second. Should be. Just give me a second here.
Sure.
I don't seem to be able to share my my screen.
Okay, let me take a look at the permissions only. Looks like. Does that make any difference?
No.
Okay, I'll